Hello student, welcome to our last lesson where we are going to continue with magnetization and demagnetization. In our previous lesson, we have seen the methods of making magnet. Now in this lesson, we are going to look at methods and ways of destroying that magnet. Now demagnetization is a process of destroying a magnet, and we have several methods that we are going to use. One, we have heating, hammering in east-west position. Then we have dropping on a hard surface. Then we have electrical method where we are going to use an alternating current. We start with the first one, hammering. Now when a magnet is placed in east-west direction and then hammered, the orientation of the dipoles are disarranged and disturbed, and therefore the dipoles at the end will face in different direction. Again, when you drop that magnet on a hard surface, the dipoles will be disturbed and disarranged, and therefore they will be faced in different direction. Make sure that you are placing in east-west direction, and we are doing so that now we can avoid the Earth's magnetic field influence. Remember, we have seen that Earth is a magnet and it has magnetic field, and that field can influence the orientation of the dipoles of a magnetic material. Now to avoid that influence, now we place our magnet east-west direction and then we hammer. Then number two, the second method is heating. So the magnet is heated until red hot and then cooled suddenly when it is resting in east-west direction. Now when you heat, you apply or you supply what we call the kinetic energy to those dipoles. They are vibrating because of the energy. Now when you cool it suddenly, that energy is withdrawn within a very short time, and therefore they are disoriented or disarranged. And because you are placing it in east-west direction, again, the Earth's magnetic field has no influence. That way the magnet is, or the magnetism is destroyed. Then from there we move to the third method that we call electrical method. Now in this method we have a solenoid, but now instead of using a direct current, we use an alternating current. And instead of placing this material in north-south direction, we place it in east-west direction. So you place the magnet that you want to destroy, its magnetism, in east-west direction, and then you pass an alternating current. Now alternating current reverses, or it changes its direction many times per second. So as it changes, the dipoles are also changing their direction, and by so doing, you'll find that at the end, the dipoles will be disoriented and they will be facing in different direction. And that way, the magnetism will be lost. Now, look at our diagram that we have here. This is an AC supply. This is our bar magnet that we want to destroy. Then we have east-west direction, and this is our solenoid. So we have seen that when you close the switch, the current will be changing directions several times. And that way the dipoles are disoriented. Then from there, we have hard and soft magnetic material. We start with soft magnetic material. Now we say that these are materials that are easily magnetized, but when they are magnetized, they do not retain their magnetism for a longer time. Examples are iron, alloy of iron, and nickel. And where do we use this? These soft magnetic materials are used in making electromagnets and making transformer cores, and they are also used in magnetic shielding. Remember, this soft magnetic material, they are very easy to magnetize, and that is why we are using them where we need magnetism very fast. That is in electromagnet and in transformers. Now we have also seen previously that a soft iron bar and soft iron ring is used to prevent subregions from getting magnetic field, what we call the magnetic shielding. So those are the 3 uses of soft magnetic material. Then from there we move to hard magnetic materials, and these are materials that are very difficult to magnetize, but once magnetized they retain their magnetism for a longer time. A good example is steel. Now these hard magnetic materials are used in making a permanent magnet. Then from there we move to care of magnet. When we are storing a magnet, how do we store so that the magnetism is retained? Remember, a bar magnet tends to become weaker because of what we call self-demagnetization. And this self-demagnetization is caused by the poles at the end, which tend to upset the alignment. They tend to destroy the alignment of the domains inside the magnet. So if we are able to prevent these poles from upsetting the alignment, then we prevent what we call the self-demagnetization, and our magnetism will be retained for a longer time. Now, to prevent this, magnets are stored in pairs with small soft iron bars called keepers placed across their ends. So unlike poles of this magnet are placed adjacent to each other, as shown in this diagram. So you have this as the bar magnet. This one has north, south, south, north. And then towards the end, we put the keepers. Then at the middle, we have a piece of wood. When you place it this way, then you are sure that your magnetism will be retained for a longer time. Now what happens is that this magnet, they magnetize this soft iron, the ones that we are calling keepers. Now they are magnetizing through induction. So this edge that is close to the south pole will form a north pole, and this edge that is close to the north pole will form a south pole. So that way we form what we call a closed loop, or there is a chain around the magnet. And now we avoid now the poles, the edges that are upsetting the alignment, because now this magnet will be having a loop or a chain of dipoles that are surrounding them. So that way we are able to avoid free poles, and that way we are able to take care of our magnet, and our magnetism of this magnet will be retained for a longer time. Then from there we move to the uses of a magnet. Then number 1, we have loudspeakers and microphones. Now you need to note that loudspeakers convert electrical signals or electrical energy into sound. So the magnet in the speaker provides a magnetic field which interacts with the field of varying electrical current. Remember, we have now the what we call the electrical field and magnetic field. They interact, and when they interact, they result in vibrations of the coil, and that way there is now, there is vibration, there is conversion of electrical energy to sound. And then number 2, we have computer hard disk, recording and reading of videotapes. Now the head of a hard disk of a computer records data on magnetic tapes or strips in the disk. Now this is done through magnetization of magnetic materials in those strips corresponding to the data input. And now when you are reading the data together with the encoding system in the computer, on command, you are able to retrieve the information for manipulation. So that way you're able to use magnetism in computers. Then from there, magnets are also used in medicine. For instance, if you have a magnetic material that has fallen in your body, for example, you have iron filings, pieces of iron filings in your eye, we can use a magnet to remove them. That is in the field of medicine. We can also use magnet in a machine that we call magnetic resonance imaging, MRI. This machine uses a powerful magnet whose field enables doctors to take pictures of internal parts of the body. For instance, if you have a problem on your spinal cord, we use MRI. And this MRI will take the photo that will help the doctor to identify the problem on that part of your body. Now, the photos that are taken using the MRI machine are more detailed than the one that are used using the X-rays. So therefore, we can say that MRI will give you a more detailed information as a doctor so that you can be able to get where the problem is. Now, the magnets are also used in what we call magnetic therapy. And when we are talking of magnetic therapy, we can use a special magnet to relieve pain. If you have a pain in a particular part of your body, we just use a magnet to relieve that pain and also to relax the body. Then from there, we have number 4, sorting and separating. When you have different materials, that is magnetic and non-magnetic material, and you want to separate the magnetic material, you just use a magnet to attract all those magnetic material, and that way you're able to separate. So we have that the magnets are used to sort and separate magnetic materials as in quarries, where metal is separated from ore. Now, very strong magnets are used to recover metallic objects from ocean bed. So if you have a metallic object which is magnetic material, then you have a very strong magnet that can attract them, and then those metallic materials are recovered. Then we have magnetic screw, drivers in lifting small screws or putting them in place during repair work. Technicians make use of magnetic screwdrivers. In other words, when you are in an industry, you work with so many magnetic materials, and maybe it may be difficult for you to correct them using your bare hands. So we use magnetic screw that will attract all the magnetic materials or all the magnetic screws and then they put them together all in a safe place. Then from there, we have several uses of magnets. For instance, they can be used in industries as stirrers, lifting iron scrap metals. Then weather stations for resetting 6 maximum and minimum thermometer. Then in navigation for showing direction as in compass needles. Then from there we have the assignment. The assignment is testing what we have just learned. So make sure that you're able to revise and prepare well before you attempt the assignment. Then after the assignment, prepare for the end of topic exam. So thank you, and let us meet in our next subject.